Now we're gonna try to find the area enclosed between the curves f of x is x and g of x is x squared. And moreover, we're gonna add the line x equals 2. Okay, so this is these functions are very easy to graph. So here we have y equals x, okay, and x squared here, this is 1, so x squared, and x is 2. X is 2 is this line here. Okay, so we are asked to find the area enclosed between these curves, between this one here, x and x squared, and x equals 2. So we are looking for this area here in red. So basically, we are trying to find the integral here between 0 and 2. We are given these two. So we are trying to find the integral between 0 and 2 of the absolute value of f of x minus g of x dx, where we have to determine where these two functions are on top of each other. So if we think of f, and in fact we have f of x is x and g of x is x squared. These two functions here, this is our f, this is our f, and this is our g. Okay, not here at this point, okay, which we have to determine. So this point is the solution for this equation. X squared is x. That means x is 0 or x is 1. So x equals 1. When x is equal to 1, we have a switch. Okay, so here, before x equals 1, that means when we are here, we have f of x is bigger than g of x. So here, when x is bigger than 1. When x is less, no, sorry, when x is less than 1. Sorry, this is the mistake. When x is less than 1. When x is bigger than 1, we have f of x is less than g of x. Okay, of course, it's bigger than 1, but less than 2. Okay? So in this case, we can get rid of the absolute value by first integrating between 0 and 1. And after that, we're going to integrate between 1 and 2. So we get rid of the absolute value. That's how we do that. So between 0 and 1, which function is on top? It's f of x, which is x. So we have x minus x squared dx. And between 1 and 2, x squared is bigger than x. Okay? That's why we have this integral. And this is, so if you try and read this one here, you're going to see that this is basically the definition of the absolute value of functions. Okay, so here when f is bigger than g, we have positive. We have f of x minus g of x. Okay, so this happens when x is less than 1. When x is bigger than 1, we have g of x is bigger than f of x. That's why we integrate x squared minus x. Okay, now we can evaluate simply. So here we have x squared over 2 minus x cubed over 3 plus x cubed over 3 minus x squared over 2 between 1 and 2 here, and here between 0 and 1. Okay, and we can get here, we can get 1/2 minus 1/3, and here we can get 8 over 3 minus 2 minus 1/3 minus 1/3 plus 1/2. Okay, so here we're gonna have 1/2. 1/2 is 1 plus 7 over 3 minus 2 minus 2 over 3. Okay, and if we try to evaluate this one, we're gonna see that we have 7 over 3 minus 1 minus 2 over 3, which is gonna give us 5 over 3 minus 1. Okay, which is 2 over 3. Okay, or something like that. But the most important thing is that when we have this change of functions, which one is on top of the other, we have to pay attention to this is the area. Okay, that's the key idea that we're gonna have to think about and to keep in mind. So when we have this, we need to see which function is on top of the other and integrate. Okay, and this example is so simple so that we can see what we have and what we need. Thank you.